Hello viewer, welcome to Elimu TV where you watch and learn. Today I want us to look at translation. We are still on types of transformation. So today we shall be looking at translation, but during our last lesson, remember, we looked at enlargement. So today's lesson we shall be looking at translation. Translation is a type of transformation. Maybe you may ask yourself, what is translation? Mathematically speaking, translation is a displacement of an object without turning it in a specific direction. Displacement of an object without turning it in a specific direction. When we talk of translation, it's important you note that any translation in the Cartesian plane, the Cartesian plane that I always talk about, can be written as a column vector. Any translation can be written as a column vector. What do I mean? We talk of points. Let's say for a point P on a Cartesian plane, this point is at point 2, 4. Remember when you are writing down these points, usually start with the point on the x axis, followed by a point on the y axis. That is the rule when you are writing down a point on the Cartesian plane. So we are saying that we can rewrite this point in what we are calling a column vector. We can rewrite that point in what we are calling a column vector. So if you are to write this point in a column vector, how would you rewrite it? It could be 2, 4. It's very important that you note that. So when you are doing translation, we rewrite the point as a column vector. So in other words, we rewrite the point such that we have x, y in that column form. So the point at the top is the point on the y-x axis. Then the other one is a point on the y-axis. This is what we refer to as a column vector. So you note that the x represents a movement of x units parallel to the x axis. What do you mean? Let's say, for example, we want to translate a point 3, 4 using we are going to translate this point. We want to translate this point by maybe 2, 1. So what do we mean? In this case? We want to translate this point P. Let's call this point P. We want to translate it by 2, 1 translation. Now, how do we get P prime? We can write this one is in column vector. This is point 3, 4. We want to translate it with this 2, 1. So 2, 1. So what do? We are saying that the x, remember, these are the points on the x-axis. The x represents a movement of x units parallel to the x-axis. So for us to get P prime, we start by translating point x. And since we are saying that x represents a movement of x units parallel to the x-axis, to get P prime, we start by getting the image for x. We take 3 you add 2 to 2 like that. Then for the y, 4 and 1, that is 4 plus 1 like that. And therefore our p prime would be 3 plus 2 you get 5, 4 plus 1 you get 5. So in other words, our p prime would be 0.5, 5 like that. I want to believe that you've understood what you've done. But now let's do another serious question whereby maybe you have a triangle and then you are given a translation vector. But before that, you'd also note that when it comes to the y, the point, this point here for y, you're supposed to also understand that y represents a movement of y units parallel to the y axis, parallel to the y axis. And also that movement to the right and upwards. If you look at the Cartesian plane, if you the positive numbers when it comes to the y-axis are from here. If this is the origin, 0, 0, so this is the positive part. When it comes to the y-x-axis, from here to here, that way you have the positive points, and these ones are the negative values, and these ones are the negative values. That is for the x-axis, negative values for the y-axis. When it comes to translation, it's also important to note that movement to the right and upwards are defined as positive. They are defined as positive. On the other hand, movement towards the left and downwards are defined as negative. They are defined as negative. Now, also note that at the translation, anytime you do what you call translation, the object and the image are usually congruent, or they are directly congruent. To sum that up, to sum what I've just said up, let's watch this video so that we can understand well about translation. We are going to look at an example when we come back.
Translation describes one way a geometric shape can move on a coordinate plane. When you translate a shape, it's like you make an exact copy of it and slide the copy to another spot. The shape stays the same. Here's how it works. Say we want to move this triangle to another location on a coordinate plane. First, we name the ordered pair for each of the shape's vertices. Then, to show where the shape is moving, we can use a mapping notation, like this, to show the translation. If we move positive 4 on the x-axis, then we know to move the shape 4 to the right. And if we use negative 2 on the y-axis, then we know to move the shape 2 down on the coordinate plane. Now we know which direction to slide the shape. Notice that the moved shape is congruent to the original, which means their corresponding angles and sides are the same. We use these little symbols to show what we've done to create this translation. So there you have it. When a geometric shape is moved on a coordinate plane, it's called translation.
Let's now look at an example and we work it out. And our example says that a triangle PQR, a triangle PQR with vertices P 2, 1, and then we have Q at point 6, negative 2, and R is at point 4, 5, is translated by a vector, negative 6, 1. So, what are the images of the triangle? What are the images of the triangle? So we want to find the image for this triangle, and that is after we do what we are calling translation of negative 6, 1 on the 3 points that have been given, that is P, Q, and R. So we are going to start by looking for the image of P, that is P prime. So our point P is at point 2, 1. Not forgetting what we said, that the x-axis represents a movement, the x represents a movement of x units parallel to the x-axis. So that means this negative 6 here is going to denote x, and this one is going to denote our y. Therefore, when it comes to not translating our P, which is at point 2, 1. So can we rewrite now this one in column vector? So we are going to have 2, 1. Then we add that to negative 6, 1 like that. So that's what we are going to do. Now, we start by working out the x. In x here we have 2 plus negative 6. Remember, positive and negative gives us negative. So 2 minus 6 gives us negative 4. So this one is equals to negative 4. And this other one here, for y, you are going to have 1 plus 1 is going to give us a 2. So that one is a 2 there. Therefore, our P prime in this case is at point negative 4, 2. Negative 4, 2. So we translate 1 point at a time. We translate 1 point at a time. Let's now go to Q. Our Q is at point 6. Q is at point 6. Negative 2. Not forgetting our translation vector is negative 6, 1. So let's also write this one in column vector. So we are going to have 6, negative 2. We add that to negative 6, 1. Negative 6, 1. So we start by our x. So we have 6 plus minus 6. And this one, if you have positive and negative, it gives us negative. So we are going to have 6 minus 6, which is equals to 0. So this one is going to be 0. Then we look at now our values for y. So negative 2 plus 1. Negative 2 plus 1 gives us negative 1. Negative 1. So that means our point Q prime. Q prime is 0, negative 1. Let's now look at our R prime. R prime. Our R is at point 4, 5. Our R is at point 4, 5. Let's start this. Let's write it in column vector. So that means 4, 5. We add to negative 6, 1 like that. We add it to negative 6, 1 like that. Then we start by solving our values for x. Our values for x. So you have 4 plus minus 6, which is equals to, remember, positive and negative gives us negative. So this one is going to be negative 2. So that one is negative 2. Then we come for the y values. 5 plus 1, which is equals to 6. And that one implies that our R prime is negative 2, 6. Negative 2, 6. So this is the solution to our problem there. So that is how we go about translation. The main thing is rewrite the point in column vector. Rewrite the point in column vector, noting in your mind that x comes up and then y. So that marks the end of our lesson, and I'm going to leave you with some assignment here to make sure that you better your understanding as far as translation is concerned. So let's look at what you are going to work out. So a quadrilateral with vertices, a quadrilateral with vertices, vertices A, -1, -1, B, 3, -1, C, 3, 3, and D, -1, -1, 3, is translated by vector -3, 4. Then find the image of that quadrilateral. Find the image of that quadrilateral at the translation by vector -3, 4, as you can see. So we are going to review that during our next lesson. Continue to watch and learn. Get back to us through our SMS number 22518. Go ahead and like our Facebook page for more tips on mathematics, especially. Our Facebook page is Elimu TV. You can also get to us through our Twitter handle. Our Twitter handle is Elimu_KE. Continue to watch and learn.